Okay, so arrays, as we hopefully know, are a group of similar variables, all of the same type, and with systematically related names that involve special syntax using the brackets. So if we have an array, we can store many different types of things in there. We can have an array that stores an integer or integers like this. We can also have an array that stores, say, characters, A, B, C, D. And Java built into these arrays, because they are part of Java's sort of base implementation, is the fact that, let's say that this is A, this is B, and then example sake, let's add another element to it. We have this built-in length, length, which you can call upon, which will always give you the number of elements in the array. So length is 4, length in this case will be 5. When we decide to call upon, or when we want to get information out of an array, we use subscripts or indexes that start at 0. So 0, 1, 2, 3, 4. And we use brackets to test whether, or test where in the array we want to reference. So A sub 1 in this case would be 5. B sub 1 in this case would be the character B. Okay, cool. That's Arrays 101, or a crash course on arrays if you forgot. And those are called array elements. Okay, so here is the original picture. Up there is a way, or a valid way, to define an array. There are other ways as well. You can simply pass it a size, in which case it will initialize an empty array of that size, and you can populate it later. You can initialize it with nothing, so you could just have int a semicolon, and it will just save space for an integer array that you can define at a later point. And then we have this diagram up here, which is just sort of an expanded version of the one that I just drew up there. But this is the original picture. Again, as we've done many times in this class, we have been lying to you. And the full story is that arrays are reference types. So instead of being stored directly in the object location that the array is defined, the bigger story, or the true story, is that we have a reference that points to the array. So instead of the array, we have a reference which encompasses everything about the array that is pertinent to us. And so, because this is the case, you could probably guess that arrays follow many of the practices that we want to use with, say, natural numbers or strings or any other reference type that is mutable, which means that based on the lecture that we had on Thursday, you should be able to understand what happens when we assign one array to another using the equal sign. So B, similarly, it is like this. We set A equal to B. What we're doing is we're setting the reference locations of each, but the object locations are not the same. You can pass an array as a parameter to a method, in which case it will be a reference type. So you can imagine what will happen there. You can return an array from a method. And then what you should not do is compare two arrays for equality with the equals equal sign, which is like the big no-no in terms of reference types. Because what does the equals equal sign compare? Does anybody remember? Primitive types? Yes. So when you use equals equals with primitive types, it will compare just the actual values. But when you use equals equals with reference types, what gets compared? You're mouthing it. Can you say it out loud? Yeah, the reference value. So the location where it is stored in memory. If you have a natural number A, which points to a natural number of value 4, and then a natural number B, which points to the natural number 4, and then you say A equals B, it will return false because their reference locations are different. Remember, there's this distinct difference between the reference location and then the object location or value. Object location or object value. So when we talk about the reference value, we're talking about the place in memory where the pointer to the actual object is stored. When we talk about an object location or an object value, we're talking about what we actually care about, which is the value of the natural number, or in this case, the value of the array. But what does equals do? So in terms of dot equals, that was the way in which we got around equals comparing the reference types instead of the object types. So instead of doing A equals B in this natural number example, if we do A dot equals B, that will return a comparison of the object values rather than the reference values. But this actually does not work with arrays. If you try to do this with arrays, it will not end up working as it does with natural numbers. Okay, it compares reference values. You might expect that it would compare elements element-wise, but the lengths of the array, but it does not. Spotbugs will yell at you if you try to use dot equals and explain that it's equivalent to the equals sign. But what do we do if we want to compare two arrays? Well, unfortunately, the answer is not as simple as you might think. You can always try to write your own code to check whether two arrays are element-wise, which is surprisingly hard to get right. If you want to, you can, I will leave this as an exercise for the reader. If you want to implement a dot equals method for two arrays, I think that's actually good practice in terms of trying to figure out the reference types. But if you're lazy, like all computer scientists, you can just use the code from Java libraries that are in the Java util package. So there's an arrays class, which is a class that you can call static methods from. And there's a static method called dot equals or dot deep equals for comparing arrays of arrays. So what we mean by that, it's not that important for the class, but it is important for computer science, the difference between equals and deep equals. But arrays can store arrays, which is just crazy. And then arrays can store arrays of arrays of arrays. They're called two-dimensional arrays. So you could have something like this, where this is F, G. I don't know why that one's capitalized. G, H, I, J, K, L, N. And if you call dot equals on an array that had the same first row as B, it would return true. Deep equals would also return true. But let's say you had an array C that was just these first two rows. Dot equals would return true. Dot deep equals would not return true. So depends on how equals you want your arrays, I guess. And we won't get into arrays within arrays within arrays because I don't want to draw cubes. Okay, java.util is the handiest package. Remember, packages are basically bits of code that you can load into your program that help you do things a lot easier than you just having to write it by yourself. So java.util has a bunch of cool methods that you can use. So it might be useful to dig into the documentation or the API, technical programming term, in order to figure out which methods are in there. Okay, best practice for arrays, after we've spent a good portion of the class talking about them, is to not use them in industrial strength software. You can imagine if you have like a like a hospital program, you're not going to be storing everybody's user information in an array. It's just not the best way to do it. There are databases and there are even better data structures to use other than arrays, but they're good for learning, which is why we use them. So we'll talk about lists. We might talk about lists. I think we talk about lists later on. That's better. Array lists are better. We talk about the OSU CSE component sequence. All of those are technically better to use in arrays, but we'll still continue to use arrays because we have a soft spot for them here at OSU. Okay, questions on arrays? Cool. Big takeaway there. Arrays are reference types, not, I guess, primitive types. I don't know. Okay, I'm going to erase it. Is that okay? Awesome. Okay. The next topic, we're going to go back to everybody's favorite topic, which is contracts. And I believe we're going to re-go over the parameter modes that we talked about briefly. Forget when. The last time we talked about contracts, but parameter modes are important to know, important to memorize, because I guarantee you there will be a question on them eventually. And if not, they're just important. Okay, so if you remember contracts, I'm going to write this again because I want to drill it into your brains. But we have the client and we have the implementer. Inside of you, there are two wolves, the client and the implementer. the client is in charge of making sure that what is correct. The precondition. Precondition. And the implementer is in charge of making sure what is correct. Postcondition. Thank you. All right. And when we want to define the fact that we want something to be true either before or after the method has concluded, in terms of the client, the precondition, we use an @requires tag. So we might require a value to be equal to some value or above certain value or not be some certain value. Postcondition has this ensures clause. The client can assume that the postcondition will be true as long as it meets the precondition, and the implementer can assume that the precondition will be true when they're working with their code. Contracts are a way for these two parts of the software engineering to interface or to talk to each other, essentially, and come to an agreement about what the method should do. So you've probably had some experience working with contracts and writing contracts with your projects, and if you haven't, you should. But essentially, anytime we give you a method to implement in a project or a homework or a lab, it usually comes with a contract, and it tells you exactly what that method should do. No more, no less, with all of the requires and ensures clause. It's a way to look at a method header, and without even looking at the actual code that's implemented, you should be able to tell me what the method does, what the variable should be, and reason about how you should use it. That's the beauty of contracts. They're important. They have parameter modes and 2 stipulations. Okay, so now that we know that there's this veil of ignorance that has been lifted off of your head, and there are these things called reference types. When we talk about parameters in contracts, we are always talking about the object value. So if we're saying that we require that a natural number is greater than 5, we don't mean that the object or the reference location should be greater than 5 in the memory. That would be silly. We always want to worry about the object value because that's what we actually care about. And then reference type arguments are always non-null, and we'll talk about null later. Parameter modes are something that is specific to Ohio State. It's not general purpose across all of Javadoc. There are no industry standards yet that govern how to write contracts, but it's something that we use so that you can test what variables should do throughout the program. And there are 4 parameter modes. So let's write those down as they come up. Does anybody remember what the default parameter mode is? If a variable does not, oh, by the way, every variable has to have a parameter mode. And if it doesn't, it restores to the default parameter mode, which is what? Play Hangman. It starts with an R. Restores. All we need. All right, restores. Which means that the variable will not change. The value of the variable at the beginning of the code will equal the value of the variable at the end of the code. Parameter modes help us in 3 ways. Concisely summarize which arguments might have their values modified by a call, make the requires and ensures clause shorter, and allow us to perform consistency checks against contracts for certain simple errors. There are 4 of them. Okay. Modes are listed for the formal parameters, including this, but actually apply to their corresponding arguments for a call, including the receiver. Lots of words. Let's break it down more simply. If we have foo, takes in natural number A, in the contract, we're going to be referring to the natural number that's passed in. We're going to be referring to that as the restores or any of the other 4 parameter modes that we have. So we might say at restores A. Because even though, or we do this because we don't know what the name of the natural number that the user is going to pass into the function is going to be. It could be called A, B, C, D, any number of things, even things that are more than 1 character, shocking. And then when we're working with instance methods, which if you remember are called on an instance of an object, we have what's known as the distinguished formal parameter, which is just this, because we don't know what the name of the object that we're calling the method on is going to be. So this is defined as a distinguished formal parameter. So if it's an instance method on a natural number, the natural number on which we call a method, such as, say, multiply, divide, add, any of the other natural number methods, the object natural number that we're calling it on is referred to as this in contracts. Awesome. Okay, first one, upon return from a method call, a restores mode parameter once again has its incoming value. This is equivalent to adding to the ensures clause that x equals, remember that hashtag means the old value, so x equals the old value of x to the ensures clause. An old restores mode parameter, e.g. old x, should not appear in the ensures clause. It should just have that restores. This is the default parameter mode. So if you have a contract and you don't see a variable, it is restores mode. So typically when you have a function and you have a bunch of different functions, A, B, C, Checkstyle will yell at you if you don't have what are known as parameter tags. Parameter tags are those at param. These are separate from the other tag, but they simply describe what the variable should do. So we might say that A gets incremented or something like that. And that's so that when a client who has never looked at the actual code looks at the contract, it can say, well, I'm passing in A. What is A supposed to do? Oh, A gets incremented. Cool. Java will yell at you if you don't have a parameter tag for every variable. You don't need these parameter mode tags for every variable, because if you don't have a parameter tag for a certain variable, Java will assume that it is at restores mode. It means that the variable does not change. Okay, one down. Here to go. Clears mode, upon return from a method call, a clears mode has an initial value for its type. So if we say that a variable is at clears mode, we mean that it will be restored to a default value. What is that default value? Typically, well, yes, typically 0 for something like natural number. If it was, say, an array, it might just be an empty array. Typically, you would look at the no argument constructor for that object class. So let's say for like a stack, it would be like an empty stack. A string, it might be an empty string, so on and so forth, whatever the default value is. Let's say we're implementing a new natural number class called natural number 4, where the default value is 4. In that case, the clears mode parameter would restore it back to 4. Mostly, though, you can look at the no argument constructor, say for natural number, it is 0. Say for array, I'm assuming it's just an empty array, so on and so forth. This is equivalent to adding and x equals an initial value for its type to the ensures clause. A clears mode parameter should not appear in the ensures clause except as old value x. So we're abstracting out a bunch of formal contract language into these parameter modes so that you don't have to write a lot of words, because computer scientists are lazy. Okay, it's possible there isn't a no argument constructor, in which case you should just see the clear method in the interface standard for technical details. So remember, everything inherits from this standard class, which has 3 methods. I'll write these down because they are important, which are clears, new instance, transfer from. And so if you don't know what the default value for a reference type is going to be, you should look at the contract for clears, which will tell you, because that's what clears does. Okay, 2 down, 2 to go. Here's an example, the transfer from method, which sets this to the incoming value of n and resets n to an initial value. So you remember, we have, say, n reference type points to 4, a reference type points to 8, and then we call n dot transfer from a. Always include something. N in this case takes the form of the distinguished formal parameter this in the contract, because that is the object on which we are calling transfer from. So n in this case is this. So it replaces n, which is one I don't think we've talked about yet. That's coming up though, spoiler alert, and it clears n. So afterwards, the value of n will be an initial value. So in this case, it will be 0. It ensures that this equals the old value of n. So the old value of n was 4. So we can ensure that after the method is concluded, A is going to be equal to 4. It was 4, right? I think so. Okay. Replaces mode. That is the third one. Replaces mode means that the variable will be replaced upon return from the code, and its incoming value does not depend on its outgoing value does not depend on its incoming value. These next one, I'm going to run out of space. Replaces and restores, pretty similar, but there's one stark contrast between the two. Replaces and updates. Okay. So value will be updated, value will be replaced, and value will be updated. You might think that these are synonyms, but the key difference is that updates depends on the incoming value, whereas replaces does not depend on the incoming value. So when we have a replaces mode parameter, we're saying, hey, this is going to get modified. This value afterwards is probably not going to be the same as when it was coming into the program. But the new value that it has does not depend on what its old value was. So if you have a natural number m pointing towards the value of 4, and you have an a pointing towards the value of 5. If both of these were replaces mode parameters, it does not matter that n is 4 and a is 5. The new value that they have after the function call has concluded does not depend on whether or not it's 4 or 5 or 8 billion or 0. Doesn't matter. You can contrast this to updates, which does depend on the initial value. So depending on whether or not n is a or a is 5, the initial value of the natural number is going to impact what the final value will be. The big example of this is .add. And wake up. So add, if you call n.add on a natural number of 5, 4, if you call that on 4, it's going to become 9. If you call that on 5, it's going to become 10. The final value depends on what the initial value is. Same for subtract, divide, so on and so forth. Okay, replaces mode parameter has a value that might be changed from the incoming value, but the method's behavior does not depend on the incoming value. So it doesn't matter what the initial value is, it's going to get replaced, potentially. Example is copy from, which copies n to this. It does not matter if we call it on a natural number of 4 or 5, because the final value is going to be whatever we're copying from, whatever this natural number n is. It doesn't matter if it's 4, 5, a billion, so on and so forth. And then finally, updates mode parameter has a value that might be changed from its incoming value. Method's behavior does depend on its incoming value. So in other words, both replaces and updates modes indicate that the parameter can change value. Notice it says can change because let's say we're copying from, we call it a.copy from, and then another natural number, or actually, we just did this. We say n.copy from a. Technically, we're updating the value of n, but the value doesn't change because it's still 5. All right. The difference is that the former, the behavior of the method is independent of the incoming value, while the latter isn't. Okay. Good so far? Awesome. Drink of water and then get after the rest of the slide. All right, so the example is add. The example that I used, the incoming value the outgoing value does depend on the incoming value. If you call add on 7 versus 12, the value is going to be different. All other things the same. So we say that it updates this being the natural number on which we are calling add. And it ensures that this equals the old value of this plus n, which is how addition works. Okay. Again, parameters stand for object values. It would be silly of us to assume that when we're talking about the parameters, we're talking about the actual memory locations that they're stored at in Java. We're talking about the object values. So example, this equals n. We're talking about the object value. So, which means that it does this. M.copy from k copies the object value of k into m. What it doesn't do is copy the reference value. It does not create aliases. Now, if you wanted this to be the result what would you have to change about this line of code right here? How would you make M and K aliases? Yeah, so M equals K will assign the reference location of K equal to M, in which case you will have aliases, which are dangerous sometimes. Okay, brief note, null references. In Java, any reference variable may be given the special value null, meaning that it does not refer to any object at all. So if you say string s equals null, we have this fancy diagram. Just is, I don't know why that's the diagram for null, but simply means that it does not point anywhere. It is like your treasure map going to basically nothing. Like the beginning of the National Treasure movies, where like they have a map and then it leads them to like a ship and like the treasure's not there. That's like basically what a null reference pointer is. Actually, no abstractions at all. Okay. This special notation to replace the arrow when a reference is null. Best practices is not to use null references. I think it's actually in the best practices document. So do not use null references, at least in this class, even though it is often easy to avoid them, and it is now considered a good idea to try to avoid making them. The most common causes of crashes in Java is what are known as a null pointer exception. So if Java is attempting to, say, print out a natural number or copy a value into another value, and it's using reference types, and it points to a null pointer, Java gets to that object value, and there's nothing there because it's a null pointer. You'll get what's known as a null pointer exception, which means that the code attempted to follow a null reference to a non-existent object to which it refers. So best practices is not to use null references. And don't take it from me, take it from the creator of the null reference value, Sir Charles something Richard Hoare from 2009, who said, "I call it my billion-dollar mistake. It was the invention of the null reference in 1965. I couldn't resist the temptation to put in a null reference, simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 4 years." So, like an unwanted child, the guy who created it does not even like the null reference. Yeah. It's pretty scathing review, honestly. It was like my favorite slide, I think, of the entire semester. Okay. OCCSC components contracts stipulate that no argument to any method may have a null reference. Hence, do not use null references. Don't take it from me. Take it from Mr. Carr. I will call him. And if you want to read about that, they have this beautiful presentation. Or not presentation, article. Okay, questions about null references and contracts and all these parameter modes and stuff. Going once, going twice. Sold. Yes.
Wait, do you assume? Wait, hold on. Yeah. Do you assume it's restores mode if nothing else is said?
Yeah.
Okay.
So if you look at a contract and you're like, hey, I'm passing in natural number A, B, and C, but B is clears mode and C is replaces mode, but A doesn't have a parameter tag, A is restores mode. Okay. Sold to repeated arguments. Okay, I'm going to erase this. Pause. So, I'll erase this. Built into the fact that reference types copy the reference values of variables as opposed to the object values, we have to talk about what happens when you pass the same reference value twice, because as an object of the fact that we are allowed to pass object values or reference types, you're allowed to pass the same reference types once or twice or even multiple times. And we have to talk about why that's a bad thing today. Okay, alias references for mutable types can cause trouble, so it's important to know how aliases may arise. The simple way that we've talked about is through the use of assignment. So if we have, sorry, the chart is the actual chart. This side. If we have natural number A points to here, natural number B to here, 5, 4, and then we say A equals B. What we then do is we set the that's not B. A equals B. What we then do is we say that A now points to this variable B, and they are aliased. So now any incrementation or any modification of the object value of B will also modify the object value of A. any modification of the object value of A will now modify the object value of B. That is the beauty or harm of aliases. That's one way to do it. The other way is from parameter passing. So before, when we passed variables into, say, a static method or an instance method, we were passing it by value. So primitive types, the values were actually copied in to the formable parameters. However, now that we've introduced reference types, instead of the actual values being passed in, it is the references to those values which are passed in. And so this causes problems or creates aliases. So as an example, let's consider this method using the brand new contract formal specifications that we've learned, which is the public-private static foo natural number x, natural number y method, which adds 1 to the first number and 2 to the second number. Both x and y are updates mode, which means that the value is going to change, and it does depend on the initial value. The outgoing value does. It ensures that x equals the old value of x plus 1 and y equals the old value of y plus 2. So when we call this method, we are going to have 2 pointers to natural numbers. So let's say that we have, I don't know why I believe that A is pointing towards 4, B is pointing towards 5. I would start getting in the habit of drawing pictures when you're reasoning about reference variables and pass by reference and just about anything to do with references, because it makes it a lot easier to figure out what's going on behind the scenes. So when we call, let's call foo A, B, what happens is that these distinguished formal parameters get defined. So we need a natural number x and a natural number y. In the old way of doing things, in pass by value, 5 would get copied into a new box, 4 would get copied into a new box. That's not what happens though. The references are copied in. So x now points to, real picture is that x gets copied in, or x points towards A, y points towards B. We've created a chain of command here where A and B point towards 5, but x also points towards A, which points towards 4, and y points towards B, which points towards 5. And that's what happens. And then, because we can read contracts, we actually know what happens without even having to look at the code, and ensures that x equals the old value of x plus 1. So x equals the old value of x, 4 plus 1. This becomes 5. And y equals the old value of y plus 2. So this becomes 7. And after the method is concluded, after we destroy x and y because they're no longer relevant to our program, A and B have still been updated. So outside of the function call in the main method, where you might have called this foo method, A and B have been updated. That's reference types, contrasted to primitive types. So that's an example of how it might go. How would you implement this contract specification? Oh, what's a way in which that you could implement this? What's a way that you can add 1 to a natural number? Increment. Awesome. We're so good with just one letter. Okay. Or what's another way that you could do it? Dot add 1. Okay, I thought I was gonna have to draw A. Okay. And then you could use dot add 2 in order to say that you are going to add 2 to a new natural number. So consider this call the method. They're using big numbers. I don't want to use big numbers. This is essentially what we just went through. We have natural number A and B, which point towards the object values of 10 and 319. And we call foo on A and B. X and Y are pointed towards these values of, I guess in that case, I guess they pointed towards the object value. Technically, it's pointing towards the references, but you can do either. And then we increment the x variable by 1, so it becomes 11, and we increment the y variable by 2, so it becomes 321. And then afterwards, x and y are destroyed, and 11 and 321 remain. Okay, aliases are created, but since the method body for foo only has access to the variables x and y, i.e. the variables used as the arguments, A and B are not in scope while the body of foo is executing. These aliases cause no trouble. So this is an example of where pass by reference is technically okay. But now let's get into a different call. Let's say that we have a natural number that just points to 10. So we only have one natural number, and then based on the title of the lecture, we have repeated arguments. So A is 10, and we have X, which points to A, but now Y, which also points to A. So if we're looking at the contract, x has to equal the old value of x plus 1. So x has to be 11. And y has to be the old value of y plus 2. So y has to be 12. But they both point towards the same reference value. They both point towards this variable a. So a has to be both 11 and 12 as the method concludes, which is impossible and scary. Again, we have a equal to 10, x and y. Now we have three variables all pointing towards the same object location. Scary, very bad. And then, so yeah, after the contract concludes, since x has to be x plus 1, y has to be y plus 2, it becomes 13 instead. But the resulting value should not be 13 because that does not satisfy the contract. X's initial value was 10, y's initial value was 10, x was supposed to be 11, y was supposed to be 12, a ended up as 13. How did we get in this mess? Well, harmful aliasing. We passed in the same reference type twice, and thus the contract was trying to fulfill two things at once and failed miserably. So what outcome was expected? We expected that a was supposed to be both 11 and 12 because a was serving as both x and y in the contract. But that's not what actually happened. What actually happened was that a ended up being 13. In this case, it would be impossible for any implementation of foo to produce the outcome supposedly ensured according to the contract. I dare you to try to create a program in which the same variable takes on two different values. It's impossible. The trouble arises from repeated arguments, i.e. a call like foo, a, and a. It's not just in Java, it's a problem in any language with mutable types. So any language with mutable reference types is going to have this problem. It's a wide-arching, cross-language, huge problem in computer science. Yeah, and this also comes up when you're talking about instance methods, because the instance method takes over the object on which you call the instance method takes on the formal parameter this, but then you can also pass something. So n.add_n would be an example of double arguments because n is serving as both this and it's serving as both the natural number on which you're calling the add method. So it's going to cause problems again. So why, given the contract for add, can this call simply not be a good idea? I believe it's because if you look at the contract, it says it updates n and it restores, or no, sorry. Okay, actually, I'm just gonna write out the contract. It's a lot easier to explain that way. If you look at the contract for add, I believe it says that it updates this, and then it doesn't have a parameter tag for the natural number n that you pass into the add method. So that would be restores. So you're saying that n, in this case, should be both updated and restored, which is impossible. Okay, so wide-arching problem in computer science causes lots of problems, is affected pretty much every computer scientist that exists. So what's the big solution? Just don't use them, which is pretty funny. We talk about why it's like a big problem. Best practice, don't use double arguments. Just avoid them. And you'll be fine. So yeah, big takeaway from this lecture is don't use repeated arguments. Otherwise, Java jail for a week. Okay. Lots of content today. Any questions on any of that? Yeah.
Is the implementer at fault for like harmful?
Ooh, that's a good question. It would be the client. Because it's just a natural law of the world that you don't use double arguments. And so, well, because let's see here. The contract for, say, this foo method would work if you pass in two separate natural numbers. It's because the client is passing in the same natural number twice that you're getting the issues. So it's the client's fault. Okay. Other questions? Yeah. Yeah. Mm-hmm.
But if we're tracing like a method call or something, we still be focusing on the references.
You're focusing on the references if you create aliases, but if you're calling a method like .add, .subtract, you focus on the object values. So anything to do with assignment, So like A equals B, that's when you create a reference. Anything to do with like an actual method that you call like an instance method or a method that modifies the object value of a reference mutable type. There we go. I think I got that right. You focus on the object value. Okay, other questions?
We pull the attendance.
Yeah, of course. Data attendance question. Give an example of the primitive type, mutable reference type, or immutable reference type. Okay, gift of time. You guys can leave. I will see you tomorrow for lab. Hopefully less cold.
So cool.
It's disgusting out, actually. I hate it.
It's brutal.
And it's supposed to be that way like all week.
We can see you tomorrow.
Have a good one. Hey. Oh, no, it's if you can't make a lab, that's totally fine.
Okay.
Mm-hmm.
Yeah, sorry, and also, I think on the 7th of March,
Mhm.
I have a military leave from Friday to
Gotcha.
Monday.
Okay.
So,
Actually, I won't even be here Friday, March 7th. So I think the lab's going to be asynchronous anyways.
okay. Thank you so much.
Yeah, of course. Have a good one.